everyone. Today we are going to learn how to reflect sine and cosine waves. Before we get started though, I would like you to please go ahead and complete this warm-up. The warm-up reads, factor a cubed minus 6a squared. For the second one, it is 2x squared minus 5x minus 12. And the third one is 4x cubed minus 625y cubed. Please look for a greatest common factor, but factor each of these completely. Please pause the video as you do this, and when you have an answer, please restart the video and we'll see how well you did. All right, so the first thing that we need to do is we need to factor. So I'm going to look at a to do the third power and 6a squared, and notice both of those terms have in common an a squared. So I'm going to factor out an a squared, and I'm left with a minus 6, and that's my answer. There's nothing more for me to do. For the next problem, I'm going to break this quadratic apart into two parentheses, splitting apart the 2x squared into a 2x and an x, and asking myself what two numbers works with the factors of 12, then works with the factors of 2 that can get me a 5. So whenever I think of the number 12, I always think of 3 and 4 and 6 and 2. So I'm going to try a combination of those problems, or those numbers. So I'm going to try 2 times 3, that's 6, and 1 times 4, that is 4. 6 and 4 can give me a 10, or 6 and 4 can give me a 2, not a 5. So I need to go about this in a different way. So let me try, instead of 2 times 3, I'm going to try 2 times 4. 2 times 4 is 8, and 1 times 3 is 3. 8 and 3, when added together, will give me an 11, and 8 and 3, when subtracted, will give me a 5. So that means I'm going to multiply 2 times 4, and I'm going to multiply 1 times 3. So where do my signs need to go? Well, since this is a negative 5, I know that 3 minus 8 will give me a negative 5. So that means that the negative needs to go in front of the 4, and the positive needs to go in front of the 3. So 2x plus 3 and x minus 4 is my factorization. Let's go ahead and look at the next one. 40x cubed and 625y cubed, both of these two terms have in common a 5. So I'm going to factor out that GCF of 5. And when I do that, I end up with 8x cubed minus 125y cubed. Well, 8x cubed minus 125y cubed, that is a difference of cubes, which means I'm going to be using square opposite product square. So I'm going to write 5 times a binomial times a trinomial, and in my binomial, I'm going to take this cube root of each of my terms. The cube root of 8, that is 2x, or 8x cubed is going to be 2x. There's going to be a minus sign in between, and the cube root of 125y cubed, that is going to be 5y. Now I'm going to do square opposite product squared. My first term is a 2x, and I'm going to square that to make that 4x squared. Opposite of a minus is a plus. Product, 2 times 5 is 10, so we're going to have a 10xy, and then squared. 5y squared is plus 25y squared, and there's my answer. 5 times 2x minus 5y, 4x times 4x squared plus 10xy plus 25y squared. All right, so our learning targets for today is for you to be able to say, I can graph a sine and cosine function using a's, h's, and k's, but this time I can also graph it when a is negative. And I can write, another thing I want you to be able to say is I can write a function. So where I want you to write functions given an amplitude, a period, an axis. Also given information like that something has been, a sine or cosine wave has been reflected, or given that it has been translated vertically or horizontally. So I'm going to give you problems like that as well. So what I have given you for these types of problems is I'm giving you two different graphs. One graph is a sine graph, and the other graph is a cosine graph. And this lesson is about how to translate and reflect trigonometric graphs. Now, whenever we have a reflection, that always meant that our a value has to be negative, and that's what we're going to see. So we're still going to follow the same patterns for sine and cosine waves that we did before, only the difference is that they're going to be reversed. Take a look at what we have for sine. So we know that sine is supposed to go 0 up, 0 down, 0. But unfortunately, that's not what we have here. we have 0 down, 0 up, 0. So it's kind of reversed in a way. Same thing with cosine. Cosine, we're used to starting up. We would have up, 0, down, 0, up. But now it's been reflected. So now we start down. Down, 0, up, 0, down. So whenever you have an A value that is negative, the graphs are reflected. They are reflections. They are reflected or reflections of the original graph. So our original graphs were y is equal to sine of theta and y is equal to cosine of theta. So whenever you have y is equal to negative sine of theta, instead of you going 0 up, 0 down, 0, we're now going to go with our y values. We're now going to go 0 down, 0 up, then 0 again. So we'll have 0 down to negative A, back up to 0, back up to A, and then back to 0. And those are going to be your y values. When it comes to cosine, y is equal to negative cosine of theta, or of x. Our y values are going to be as follows. Instead of starting up, we're going to start down. So it's going to be down, 0, up, 0, down. So we'll start with a negative A, then 0, then up to A, then back to 0, then down to negative A. And so everything that we've learned so far is going to be the same. The only difference is that instead of us going 0 up, 0 down, 0, we're going to be reversing it or reflecting it. So any value that was positive will now be negative. Any value that was negative will now be positive. Everything else that we've done is going to be essentially the same. But the one thing I need you guys to know is that whenever you're graphing these types of functions, our amplitude will always be positive. Because amplitude represents the difference, half the difference of the maximum minus the minimum. And whenever we subtracted the maximum minus the minimum, we always ended up with a positive answer. So our amplitude will always be positive. So a lot of kids make a really silly error whenever they're trying to graph these types of functions, is they see, oh, there's a negative 3 right there. Cool, that means that this is going to be a reflection. So my amplitude is automatically the A value, which is negative 3. But remember, the amplitude there is going to be the absolute value of A. So in this case, the absolute value of negative 3 is going to be positive 3. So amplitude is always going to be positive. Please make sure that you write that down someplace. It's always positive. It's still going to be that number, that A value that's in front, which is important, but it's just going to be a positive version of it. So whenever we graph these problems, it's always helpful to identify your A value. A is negative 3. Our B value is 1/4. Our H value is the opposite of what we see inside, which is pi over 4. And our K value is what we're adding on the outside. And in this case, our K value is 0. We still find the period the exact same way. So that's going to be 2 pi divided by our B value. Our B value is 1/4. So this might be something where you want to be careful. So if we went 2 pi divided by 1/4, that means that we're going to be multiplying by the reciprocal of the second fraction. So that's 2 pi times 4 over 1, and that is going to be equal to 8 pi. So our period in this case is going to be 8 pi. Our midline is still based on k, and that's going to be y equals 0. So if you wanted to graph y is equal to 0 from the very beginning, just so that that is done and out of the way, that's not a problem. You know that y equals 0 is certainly going to be a part of your graph, and I'm going to use a pink highlighter in order for me to graph that. Next, we need to identify the 5 key points of our basic function, and that basic function in this case is going to be your function without h and k. So that's y is equal to negative 3 times the sine of 1/4 x. So we always write this without h and k. So that's what I'm writing without h and k. And so these are going to represent my original x value, or original x and y values that will help me when I incorporate my translation vector. So I'm going to start with my x value. Since this is sine, I'm always starting at 0, 0. So I'm going to put down 0, 0. And then in order for me to find my x values, I'm going to multiply my period, which is 8 pi times 1/4, 1/2, 3/4, and 1. So I'm going to multiply 1/4 times 8 pi, and I end up with 2 pi. 1/2 times 8 pi, and I end up with 4 pi. 3/4 times 8 pi, and I end up with 6 pi. And then 1 times 8 pi is 8 pi. And now since this is a reflection, instead of me going 0 up, 0 down, 0, I'm going to go 0 down to my a value, which is -3. Back up to 0, then up to +3, then back down to 0. So 0 down, 0 up, 0. Now my translation vector, since h is pi over 4, I'm going to write pi over 4 first, and then my k value is 0. And what this means is that I'm going to add pi over 4 to all x values. And what that indicates is that I'm going to have a horizontal shift pi over 4 units to the right. So I'm going to have pi over 4 units to the right as my horizontal shift. So I'm going to add that to all of my x values, and I'll show you what to do in just a second. Then because my translation vector has a 0 in the y position, that means that all y values remain the same. And what that means is that there is no vertical shift. So that is something to keep in mind. Okay, so now let's go ahead and shift our ordered pairs. So I'm going to take 0 and I'm going to add pi over 4 to it. 0 plus pi over 4 is pi over 4. Then I'm going to take 2 pi and I'm going to add pi over 4. So if I were to go 2 pi plus pi over 4, I can make myself have a common denominator of a 4, so that's going to be 8 pi's over 4. By multiplying my number by 4, and I end up with 8 pi's over 4, plus pi over 4, that's going to give me 9 pi's over 4. So 9 pi's over 4 will go into that next position. Then my next ordered pair, we have 4 pi's plus pi over 4. So that's going to be 16 pi over 4 plus pi over 4, which is 17 pi over 4. Then I'm going to take 6 pi plus pi over 4, and I'm going to have a common denominator of 4 to make that 24 pi over 4 plus pi over 4. And now we have 25 pi over 4. And finally, we have 8 pi plus pi over 4. So that's going to be 32 pi over 4 plus pi over 4, and that's going to equal 33 pi over 4. So those are my ordered pairs, or my x values that I'm going to be working with. Now, because my y values do not change, I'm just going to rewrite them down. So we have 0, -3, 0, 3, and 0. And these ordered pairs are the ones that you need to graph. So please make sure that you graph them. You do not want to graph the original ones that you have up here, because that has nothing to do with the function that we're supposed to graph. So what do you go by? What scale should you go by? Well, the scale that you need to go by is the second x value of the first table that you come up with. So I'm going to make everything go by 2 pi. And I'll show you how to graph 9 pi's over 4 in just a second. So I'm going to go by 2 pi. So I'm going to make every thick line 2 pi. So here's 2 pi, here is 4 pi, 6 pi, 8 pi, 10 pi. 12 pi, 14 pi, 16 pi, and 18 pi. And going backwards, I have -2 pi, -4 pi, and -6 pi. My maximum is going to be a 3, and my minimum is going to be a -3, so I'm just going to go by ones. So I'm going to count 1, 2, 3, and 1, 2, 3. Here's -3. And so now I've labeled my graph appropriately. I have my x and y value, or x and y axes labeled, and now I need to figure out how on earth I'm going to plot pi over 4 on a scale using a scale like this. Well, there's going to be some approximation that's going to take place. So I'm going to take pi over 4, and I'm going to plot, I know that approximately pi over 4 is just a little bit. If I know that every single big line is a 2 pi, that means every little line has to be a pi, which means that pi over 4 is going to be just past 0. So I'm going to plot pi over 4, 0. And then I'm going to go 9 pi's over 4. So where's 9 pi's over 4? Well, it's 2 pi over 4 plus a little bit. So I'm going to go to where 2 pi is, so I'm going to go to where 2 pi plus pi over 4. And where's 9 pi over 4? It's just a little bit more than 2 pi. So I'm literally going to go to where 2 pi is, go a little bit in front of it, and I'm going to go down to where -3 is. And I'm going to plot a point. It's just, it's not directly on the line of where 2 pi is, just a little bit in front of it. So then I'm going to go to where 17 pi over 4 is, which is 4 pi plus a little bit, and I'm going to make that at 0. And then we have 25 pi over 4, which is 6 pi plus pi over 4, which is just going to be a little bit in front of that, and that's going to be up at 3. Then we have 8 pi plus pi over 4, so that's going to be just a little bit in front of pi over 4. And I'm going to continue. I can draw my pattern at this point, making sure that it looks smooth and curvy, and then decide where I'm going to make the rest of my points. That's just another approach, another strategy. So then, and now I'm going to go in just a little bit in front of 10 pi and go down to where -3 is. And then I'm going to go back to 12 pi and go back to 0, just a little bit in front of 12 pi. And then at 14 pi, I'm going to go up to 3 and make my point just a little bit in front of that point, or that line. Back to 16 pi and make it just a little bit in front of that, right at 0. And then down at 18 pi, I'm going to go down just a little bit in front of that point and make my smooth curve. And my end behavior has me reaching a minimum point and then going right back up. So now on the other side, what are we supposed to do? Well, notice that all of our points were just a little bit in front of that main line, just a little bit in front of that 2 pi. So just a little bit in front of -2 pi, that's where my next point is going to be. Just a little bit in front of that. So I want to make sure that I'm consistent. And I'm going to go up because I can anticipate that I'm going to be going up to that next point, up to 3. So I'm at 0 because it's supposed to go 0 down, 0 up, 0. So we're going backwards, 0 up. And then I'm going to go just a little bit in front of -4 pi back in front at 0. And then at -6 pi, I'm just going to find a point that's just a little bit in front of -6 pi. And then that's going to curve right back up. And that is the end of my very first graph, of a reflected graph. Just like in the other lessons, I have the other problems, the even problems already finished for you. So what I'm going to do now is, this is the end of example number 1. I'm going to go ahead and show you example number 3. So in example number 3, we have y is equal to -3 times the sine of 1/2 x plus 2. So what I'm going to do is I'm going to identify my a value as -3. My b value is equal to 1/2, but what's my h value? Well, notice that there's no parentheses, so it might be helpful to rewrite this equation as y is equal to -3 times the sine of 1/2 times x minus 0 plus 2. So in this case, we have our h value is equal to 0 and our k value is equal to 2. My amplitude, remember that amplitude is always positive, so that's very important that we note that it is always positive. So we're going to take the absolute value of -3, and the absolute value of -3 is +3. That's our amplitude. My period is where I'm going to go 2 pi divided by my b value. My b value is 1/2. So once again, I'm going to be working with fractions and taking 2 pi and multiplying it by the reciprocal of the second fraction, which is 2/1. And we end up with 4 pi as our period. My midline occurs with k, so that's going to be at y equals 2. And we're going to start off by graphing the 5 key points of our basic function of y is equal to -3 times the sine of 1/2 x. So I'm going to identify my ordered pairs. My ordered pairs for this problem, since it's sine, I'm going to start at 0, 0. And I'm going to go 0 up, 0 down, or sorry, excuse me. So I'm going to identify my x values. My x values are going to be based on my period. So I'm going to go 1/4 times 4 pi, 1/2 times 4 pi, 3/4 times 4 pi, and 1 times 4 pi. Half of 4 pi is 2 pi. I'm sorry, 1/4 of 4 pi is pi. Half of 4 pi is 2 pi. 3/4 of 4 pi, that is 3 pi. And 1 times 4 pi is 4 pi. And now, because this is a reflected graph, we're going to go 0 down, 0 up, 0. So we're going to go 0 down to -3. 0 up to +3, and then back to 0 again. Our translation vector. Our translation vector is going to be located at HK, so that's 0, 2, and what that indicates is that all x values will remain the same. And if they remain the same, then that indicates that we have no horizontal shift. And our y values, we're going to add 2 to all y values, which indicates that we have a vertical shift up 2 units. So that means that all of my x values get to remain the same. So I'm going to start with 0, pi, 2 pi, 3 pi, and 4 pi. And then my y values, they're going to change. So 0 plus 2 is 2, -3 plus 2 is -1, 0 plus 2 is 2, 3 plus 2 is 5, and 2 plus 0 is 2. These are the points that we are going to graph. So what should we make our x values go by? Well, it's always going to be the second x value of our first table, and so we're going to make all of our x values go by y's, or go by pi's. So what I'm going to do is I'm going to label my graph, and I'm going to make this pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, and 9 pi. And going backwards, we have -pi, -2 pi, and -3 pi. Our minimum value that we're going to be graphing is -1. Our maximum value is 5, so I'm going to go by ones. So down here at -1, I'm going to plot -1 and count 1, 2, 3, 4, 5, and this is up to 5. With our midline is going to be at 2, so I'm just going to count up 2. And I'm going to draw a dashed line. So we always want to draw our midline or our axes located at y equals 2. And I'm going to use my highlighter. And what this indicates is that our x axes shifted up essentially 2 units. So now I'm going to plot my ordered pairs, my final ordered pairs, by starting with 0, 2. And I'm going to go down at pi, -1, then 2 pi back to 2, then 3 pi up to 5, then we have 4 pi back to 2. and I'm going to continue with this pattern. If you want to draw your first cycle, that's not a problem. And I know that I'm going to go down to -1, back up to 2, then up to 5, back down at 8 pi is going to be at 2, and at 9 pi I'm going to go down to -1. So this should look consistent. Try to make it as smooth as you possibly can. And I anticipate that my arrow is going to point right back up because I've reached my minimum value. To the other side, I would anticipate that it's not going to go down again, it's going to go up. So at -pi, I'm going to go up to 5. At -2 pi, I'm going to go back to 2. And at -3 pi, I'm going to go to -1. And here's my arrow. And the end of this function. So hopefully this wasn't that bad for you. So what I would like you to please do at this time is go ahead and pause the video and try examples number 2 and example number 4 on your own. Let's see how well you do with those. Those are going to be cosine functions. So once again, pause the video, and then I will go ahead and show you what those answers are, and then we will finish up the discussion notes. All right, here's the answer for example number 2. For example number 2, what I did is I chose to make my scale go by pi's over 2. And so I made that pi over 2, pi, 3 pi's over 2, 2 pi's, 5 pi's over 2, 3 pi, 7 pi over 2, 4 pi, and 9 pi's over 2. And to the other side, I have -pi over 2, -pi, -3 pi over 2. In this case, I added -pi to all of my x values, and this is the horizontal shift, pi units to the left. Let's go ahead and look at example number 4. For example number 4, I decided to make my x values go by pi's over 8. So I have pi over 8, and I literally wrote 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8 as just pi, and 9 pi over 8. You do not need to simplify these fractions. Feel free just to write them down in chronological order. If you know that 2 pi's over 8 is pi over 4, you know where you're going to be plotting your points. So when you have pi over 8, 1, you know that you're going to plot it right there, and then where it says pi over 4, you know that that's 2 pi's over 8. And so if that's helpful for you to continue on with the pattern, that might be a good thing. In this problem, we had to shift the graph up 1 unit, so I ended up skipping a line and making that 1, and skipping a line and making it 2. And so that's how I made my scale. All right, let's go ahead and move on to example number 5. For example number 5, I would like you to go ahead and write a sine function for a graph that has an amplitude of 4 and a period of 6. So notice that there doesn't exist any horizontal or vertical shifts, so that indicates that we're going to be working with y is equal to a times the sine of bx. So we're not working with h's and k's in this case because we don't have any information about it. What's really nice is that we're told that the amplitude is 4, so we know that a is equal to 4. And our period, well, our period is not b. We need to find what b is. So our period helps us to find what b is, but our period is not b. We need to find that. We know that period is equal to 2 pi over b. And if our period is 6, I'm going to take 6 and set it equal to 2 pi over b. And using cross product, I end up with 6 times b is equal to 2 pi. And dividing both sides by 6, we find that b is equal to 3 pi, or to pi over 3. So because it's equal to pi over 3, I'm going to write and I know that my a value is equal to 4. I'm going to write my function as y is equal to 4 times the sine of pi over 3 times x. And there's my answer. Let's go ahead and look at example number 6. In example number 6, it says write a cosine function for a graph that has an amplitude of 1/3, a period of 2, it is reflected in the line y is equal to -1. Okay, so this word reflected indicates that our amplitude is going to be negative. So what we know is that we're going to be working with our A value equaling a -1/3. So our amplitude is A equals -1/3. A period of 2 means that we need to find what our B value is. So we'll have to find that. And then it's reflected in the line y equals -1, which means that we're working with our h's and k's. Notice that we don't have any information about h. We don't know that we've had a horizontal shift in this case. So our basic function is going to be y is equal to a times the cosine of bx plus k. And in this case, our k value is going to be equal to -1 because our k value is related to our axes. So I know that k is equal to -1, my a is equal to -1/3, and now we need to find my b value. So I'm going to take 2 and set it equal to 2 pi over b because my period is 2 and my formula for period is 2 pi over b. So I'm going to use cross product and I end up with 2b is equal to 2 pi. Dividing both sides by 2, we find that b is equal to pi. So therefore, I have all the information that I need in order for me to write my function. So my function is going to be y equals -1/3 times the cosine of pi times x minus 1. And that's my answer. So now I have written here 2 more examples. The next example says the graph of y equals negative sine of 5x is translated down 4 units and pi units to the left. So if it's going down 4 units, that indicates that we have a vertical shift 4 units down, and that deals with my k value. So that indicates that my k value is going to be -4. My pi units to the left indicates that we are going to have a negative h value. So that indicates that my h value is equal to -pi. So I'm going to write my equation as y is equal to negative sine of 5, and in parentheses, I'm going to go x minus h. So minus -pi is what I'm going to write. You have to be careful with your signs. Minus -pi will indicate that we will have a plus pi inside of the parentheses. And then we have a -4 as our k value. And that is our function. And finally, we have the graph of y equals 1/4 times the cosine of 2x is reflected over the x-axis, then translated up 4 units. So we have ourselves a reflection. So that indicates that my a value will become negative. So if my a value is 1/4, my a value will now become -1/4. And it's translated up 4 units, which indicates that k is going to be equal to 4. I have no information about h, so that indicates that I'm not going to have parentheses in this problem. So I'll have y is equal to -1/4 times the cosine of 2x and then plus 4. There are going to be problems similar to these problems on your test, and I just wanted to make sure that you get enough information and enough practice in order for you to do well on those problems. That is the end of this lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.